Professor, please explain the scientific method to us.
Sure, monkey. The word science comes from the Latin scientia, meaning knowledge. Science is a method of obtaining knowledge using observation and experimentation to explain phenomena. There are many methods of scientific inquiry, but they are all based on these core principles: observation, hypothesis, prediction, experiment, and conclusion. Hypothesis is a possible solution to a problem based on knowledge and research. The hypothesis is a statement that defines what you think the outcome of your experiment will be. It's important to use as many sources as you can find. Your prediction lets you get specific. How will you demonstrate that your hypothesis is true? The experiment that you will design is done to test the prediction. This is the part of the scientific method that tests your hypothesis. An experiment is a tool that you design to find out if your ideas about your topic are right or wrong. The final step in the scientific method is the conclusion, where one determines if their hypothesis is correct or not.
Hypotheses are assumptions, and theories explain the hypotheses. We form a conclusion that the theory is either possible or not possible. This is why in science it is crucial to understand the difference between objects and concepts, nouns and verbs, adjectives and adverbs, hypotheses and theories. We can say, I see a field of corn. The corn stalks wave in the wind. I have a dust particle in my eye. But fields, waves, and massless particles are concepts in math which do not exist in physical reality, therefore should not be presented in the hypothesis. We describe or illustrate objects in the hypothesis. We explain concepts in the theory. We never explain objects. We describe them, illustrate them, or point to them. Reality does not depend on human perception or observation. It is because the human senses are limited and flawed that science must be objective. The scientific method should be observer-independent as much as possible. A rational key term never invokes an observer. In science, one must be able to visualize the concrete object. Objects must be illustrated in the hypothesis. The objects are the actors. The key terms make clear the meaning of the script, and the statement of facts sets the initial scene for the theory. The dynamic concepts in the theory are describing the phenomena of the hypothesis. The hypothesis is a photo, static. The theory is a movie, dynamic. Science, especially physics, is conceptual. Technology, which is mostly trial and error, is empirical. Planes that fly, microwaves that heat, and GPS devices that measure your position work primarily through trial and error because of technology, not because the theories that they are founded upon are correct. Theoretical physics predicts or describes, but does not explain. It is not an explanation when Newton tells me an apple falls at 9.8 meters per feet per second. I can point at an apple and say, look, it's falling real fast. So what? What is the physical medium that attracts objects to each other? That's the question for science. Math predicts how fast something falls to the ground, but it says nothing about the physical mediator, the how of the phenomenon in question. Albert Einstein said, "Since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore." Ptolemy predicted to a high degree of accuracy the position of the planets in the solar system, but he had the Earth in the center. That does not help explain why the planets orbit in elliptical paths and don't fly out into space. What about these predictions? If I observe an apple fall a few times and measure the speed and distance traveled, I can predict how fast an apple falls. What does that tell me? It does not tell me when an apple is going to fall. Now that would be a real prediction. Something that already happened, a consummated event, is described and should then be explained. Something that we have observed happen repeatedly can lead us to think that there is a high degree of probability that it will happen that way again, but that's not really a prediction. It's an educated guess. Mother Nature deals in possibilities, not probabilities. Belief, truth, evidence, and proof are not part of the scientific method. It is observer independent. Observation is what led us to the scientific method. It stops at the hypothesis. Experiments and observation are extra scientific. Science, especially theoretical physics, is conceptual. Technology, mostly trial and error, is empirical. After hundreds of years of experiments and predictions, there are no physical mediators to account for the invisible, that is, light, gravity, the atom, or magnetism. It's time for a rational scientific method. Hypothesis, theory, conclusion. Hypothesis, illustration of objects, definition of key terms, statement of the facts, the assumptions. We assume in the hypothesis stage, if the assumptions are rational, then we can proceed to the theory. The objects of the hypothesis are described or illustrated. A photograph, static. Theory, explanations of the hypothesis. Phenomena, such as motion or process, dynamic. Conclusion, possible or not possible. Everyone decides for themselves. If the key terms of the hypothesis are ambiguous, circular, synonymous, or contradictory, then the theorist should throw out the hypothesis or present precise, rational definitions of key terms upon which the hypothesis depends. The theory is where we present a movie or series of illustrations of the phenomena or process involved in explaining the hypothesis. Then and only then can we form our conclusion. If we conclude the hypothesis is not rational and therefore not possible, we throw the theory out. If the theory does not follow from the hypothesis, then it is not rational, and so we erase the whiteboard and start over. If we conclude that the theory is possible, then we may publish a paper or hold a conference. If we conclude that the theory is possible but does not provide the complete explanation, we form another hypothesis based upon the theory and build upon it. The flat earth becomes the round earth, which becomes the sphere, which becomes the oblate spheroid. Once the theory is presented, science is done.